Okay, this is slide number 71 in the class notes. Free fall, the velocity of a piece of chewed gum. Someone threw this gum off a building. I don't know who comes up with these problems. Is negative 92.3 meters per second. We need to find how long the gum's been falling for and then what distance it fell from. So for this one, like I always say for free fall, it's good to draw a picture. So here's your gross piece of gum, and here's your building. Don't ever do this, people. Don't throw your gum off a building. We know that if we assume that it was just dropped, if it doesn't give us an initial velocity, it doesn't say that someone threw it down with force off of the building, so we're going to assume that it was dropped and that the VI is 0. And then once it gets to, we assume the end of its flight just before it hits the ground, it is negative 92.3 meters per second. That's what its velocity has sped up to. And actually, now that I'm rereading it, it doesn't say that this is at the end of the flight. This could be somewhere in the middle. We don't know. Just at some point in the flight, it reached a velocity of negative 92.3. So we need to find, once it gets to that point, how long has it been falling for? So our two equations that we use when we deal with free fall are here. So we need to figure out which one we want to use. So we're going to solve for time. So both equations have time in it. We're given a VF and a VI. So we're going to use this equation because this one doesn't have VF in it. So this one's going to help us solve for time. So G equals VF minus VI over T. We know that G, since this gum is in free fall, it's going to accelerate at the acceleration of gravity, which is negative 9.8 meters per second squared. So we're going to rearrange this to solve for time. So you would multiply time over here and then divide by G. So you end up just switching places with the G and the T. So VF minus VI over G. Let's plug in what we know. VF was negative 92.3, VI was 0, and G was negative 9.8. I usually take out the units when I do out the work, just so it doesn't confuse the equation, and then I'll add them in at the end. So 92.3 divided by 9.8. Oop, 9.4. Negative signs cancel, which is good. We can't have a negative time. So if you end up with a negative time ever as your answer, you did something wrong. So it's been falling for about a little over 9 seconds. So then we need to figure out what distance has it traveled in the 9 seconds. So for distance or displacement, you're going to use this other equation because delta y will give us a distance, a vertical distance. So delta y equals VIT plus 1/2 GT squared. VI is 0. Love it when that happens because that guy goes away, becomes 0. We're solving for displacement. 1/2 negative 9.8 times our time that we just solved for here, 9.4 seconds. And that is squared. So when you plug this in, you want to do that 9.4 squared first, times 9.8, and then times 1/2, which is the same as dividing by 2. And we get 432.96. We'll round that up to 433. And there's a negative sign in there, so it's a negative displacement. What did I say? 433 meters. So a picture, another reason why a picture helps is because you can check to see if the direction of your answer makes sense, it makes sense that we got a negative displacement because the gum is falling. All right, don't litter.